Okay, very good morning and selamat pagi semua. Very welcome to the Data Science Introduction to Machine Learning Without Coding. So from the title, you know, this workshop actually won't involve any programming coding, but it is something a very good introduction to what is machine learning and how to apply machine learning in your job. Okay, so I introduce myself. I'm Kiong. I'm a professor from Faculty of Computer Science and Information Technology, University of Malaya. So maybe as an ice-breaking section, I will go around all of you to introduce yourself. Maybe I start with Puan Shida.
Assalamualaikum and very good morning. My name is Nur Shahida binti Abdul Wahab. I'm as IT officer at Faculty of Computer Science and Information Technology.
Assalamualaikum. Good morning. My name Wan Muhammad Hasanul Ishraf bin Wan Yusof. My job scope in server.
Thank you.
My name is Uswadi Hussein, Assistant ICT Officer.
Thank you.
Assalamualaikum and good morning. My name Muhammad Farhan bin Abdul Rahman. I'm as computer technician. My job scope is maintaining and repairing computer.
Okay, thank you.
Hi, morning. I'm Aziati from Faculty of Computer Science.
Thank you.
Hello, good morning. My name is Fadila. I'm an IT staff from Computer Science.
All right.
Thank you.
Thank you very much. Okay. So let's all of us have a quick overview how machine learning can be implemented for industry. All right. So I give you an example of what has been implemented in Infineon. So let's watch together this video.
Failures in building equipment can cause real trouble, be it in its operations or the well-being of its occupants. By avoiding unscheduled downtime, 30 to 40% of maintenance costs can be saved, and equipment's lifetime extended by 20%. Smart technology can already prevent those failures from happening by implementing predictive maintenance. Building assets' conditions can be monitored in real time, and failures can be predicted. This way, maintenance can be triggered at the optimal timing, before failures even occur. As part of a building's infrastructure, HVAC equipment is predestined for implementing predictive maintenance. At Infineon, we already have the technology that enables predictive maintenance today. Our Zensiv portfolio of highly accurate sensors monitors various parameters at every crucial element of HVAC. Their data is processed with our XMC microcontroller family in real time. Thanks to our Wi-Fi connectivity solutions, data is sent to the cloud, while our Optica Trust family securely ensures its integrity. Predictive maintenance is not just simply collecting data. It relies on data modeling, sophisticated analytics, machine learning, and much more. That's why we at Infineon are partnering up with experts to create compelling end-to-end solutions for condition monitoring and predictive maintenance. Be smart and prevent failures before they even happen. Part of your life, part of tomorrow. Infineon.
Okay, so that is the overall view of what has been done in Infineon. They use a machine learning for their predictive maintenance. For example, to maintain their aircon, right? For the schedule maintenance for their machine, and for the asset management for their smart building. Okay, so we have a small activity here. Can you give an example of how machine learning can be implemented in your job scope? Okay. So this is an example of the dashboard that I think FSCIT have developed. Right? recently. So this is a typical example that you can use machine learning to automate the dashboard prediction. For example, here is a dashboard for KPI. So one of the example you can think of is you can use predictive model from machine learning to predict, for example, KPI for certain indicator, all right, based on some attribute. Okay, for example, you can predict how many new student intake for the coming semester, for example, based on the applications information from the students, right, from different source. And from the student number you predict, you can allocate in advance the resources you need. For example, the venue you need to allocate for the new program to actually support the number of students you are going to have. I want to give you a small exercise now, everybody. I think you can access to this Google form. Please write down your name and your job scope, a brief description of job scope, and you try to think of one of the application the machine learning can help in your job. Okay, so everybody have about 5 minutes for this small exercise. Okay, Wanshida, you want to give a try?
Okay, for example, as a faculty ICT procurement, every year we are doing procurement on ICT equipment and also the software. So how machine learning can address the gap is by predictive ICT procurement, which is budget by year.
Yes. Okay, so thank you. So this is a very good example that you can use based on your historical record. All right, from the past year, how the procurement activity, actually you can try to predict ahead what will be the budget or what are the coming procurement you need to do for the coming years. Okay, may I have another trial from Farhan?
Okay, for my job description, PC maintenance for computer, and then the how ML adjust the gap is schedule the maintenance by monthly or and then predict the faulty part. Okay.
Okay, thank you. So this is a very good example of predictive maintenance. So, for example, for the asset maintenance in your faculty, it is very important that you always have enough stock for the spare part for all kind of maintenance. But if you buy too many spare part, it will be very costly. So it will be good you have the kind of estimation of how many spare part you need, for example, for this year, based on the prediction from the machine learning. Then you can optimize your cost and your space, right? So that is the main motivation behind that you attend this workshop. Okay, from university level, this is actually in line with the Smart Campus initiative from University of Malaya. So for faculty level, right, in line with the Smart Campus initiative, so we will have the faculty will have a Smart Faculty initiative. Okay, and to support this initiative, we need to train the talent. That's why today you are here to learn this, to attend this workshop to learn about machine learning. Because through this workshop, we can actually train you to know what is machine learning and how to apply in your job. So the learning outcome of this workshop will be, by the end of this section, you will be able to build a machine learning model using RapidMiner. Later, I will explain what is RapidMiner. RapidMiner is a very user-friendly software that you can develop any machine learning model without coding. Okay, for any newcomer for machine learning, the always challenge is you must have a programming skill, right? Like need to know how to program in Python, in C++, whatever language. And that is a main challenge. You need a learning curve for that. If you don't have the basic, it's quite difficult for you to enter into machine learning application. But with this software, you are able to learn machine learning in a very fast pace and even without programming knowledge. So what will you learn out of this workshop is, first, you will learn about the core concept of what is data and what is machine learning and what is data science. What is the relationship of machine learning to data science? Second, you will learn the basics of RapidMiner, how to use RapidMiner, what are the functionality of RapidMiner. And third, you will learn how to build a machine learning method to solve your job requirement or the need of your job, to optimize your job and the efficiency of your operation, right, in your job scope. So this is a lesson plan that I planned for you for today, 3 hours workshop. We will start with the introduction to what is data, what is machine learning, and what is data science, followed by the basic of RapidMiner. Okay, then we will actually learn from a hands-on exercise based on 4 use case study, which might be related to your job. Okay, so the whole lesson will take about 3 hours. Okay, what is machine learning? Okay, machine learning actually is a computational model that can map input data to an output prediction. Okay, this is a very simplified definition. The main important you need to know is what is the input and what is the expected output you want. For example, just now, Puan Shida give the example of to predict or estimate budget, right? So the budget will be the output that you expect. Okay, and the input could be all the, for example, the e-procurement information you collected from previous year. All right. So now you can build a model based on the document you have from the past year to predict ahead now what is the estimated budget for this year, for example. So the estimated budget will be the output. Input will be the information from the e-procurement, and output will be the estimated budget. Example, right? So for Farhan also, right? Farhan, your example just now is about schedule maintenance, right? So your output estimate should be the estimated, the schedule maintenance to come out an optimized schedule, right? So the input could be, for example, the record of all the spare part you have been used, for how long, what kind of spare part, from where the spare part, the supply chain, okay, all this information. So all this become the input, and the output from the machine learning model will be your schedule maintenance. So other than that, you can see many of applications in our real life now that maybe you are using also using machine learning. Example, how to detect spam email, okay? You can actually use machine learning to detect any incoming email, whether it's a spam email or not. All right. So this is an application of spam filtering. You can do audio to text transcription. For example, in any meeting in your faculty, you don't have to write down manually the minutes. You can actually use the speech to text conversion from any machine learning model to transcribe the voice or the speech during the meeting into the minutes automatically. This is a second application. Right? And so for another side, translation, you can translate Malay to English, English to Malay automatically using a translator. So all this can be done by machine learning. So machine learning in general had two types of model. If you are predicting output which involve just label, a discrete label or a name of something, we call it class, right? For example, face recognition, right? So you use camera for biometric, for example, you can recognize who is the ID and who is the person. So the output will be the name, right? Just a name, right? Can be David, can be Kiong, or can be any name. So the label is just a name, all right? There's no real number. So that is called a classification model. So this is the first type. If the output involve a numerical number, like for example, budget for next year, for example. So the budget itself is a number, all right? So that kind of model, we call it regression. Okay, so when you're predicting real number, it's called regression. When you're predicting a label, it's called classification. So two types. Okay. And how the machine learning learn, right? For human, we learn from experience, right? From education, formal, informal education. So, and the experience we face in daily life. So human learn from experience. For machine learning, it learn from data. So data provide the experience to machine learning, right? Just like human learn from experience. So machine learning learn from data. So what is machine learning? Machine learning is an algorithm or computation model that learns information from data. So you know there's a difference between data and information. Data just a raw data. Okay, so data can be a useful data or not useful data. Okay, but information is something we extract that we feel useful from data. Right? So machine learning is a computation model that learn information from data. So information is more useful to human, okay, compared to data. So in order to understand what is machine learning, you need to understand what is data. Okay, so let's start with the core concept of data. Okay. So in general, data can be anything, can be measured or described in a sequence of number. So the keyword is number. Anything that can be processed by computer or machine must be in a numerical form. All the machine or computer, the basic is processed in binary, right? Binary system, right? So this is a fundamental of the information they process. So everything is numerical form. For example, how to represent hello. Hello is a text, right? It's a form like normally we use, right? So how to represent hello, the text in numerical number. So in a computer system, they use a table called ASCII table, right? How many of you know about ASCII table? Do you know about? Okay. Shida, you know, right? So ASCII table actually is a lookup table that already predefined for any computer system. For example, if you want to represent H, right, then you look for H here, for example, right, H. So H actually will give you a number that represents H. So when you input the computer, it will input this number instead of the text, right? The text cannot be understood, right, by computer, but it can understand the number. So we have a lookup table, right, that you can refer to represent all kinds of characters and symbols. For example, hello in the ASCII table is 66, right? In binary form is this number. So computer can process this number, right? So when you input H, then actually you're telling the computer to process this number. And E is represented by another number and so on, okay? So you can represent any kind of character and symbol in number by referring to ASCII table. And how to represent the shape of certain character, right? So for example, H, right? We want to represent the shape of the H, right? Okay. So the shape actually can represent in the matrix form like this. So in computer, actually they understand a binary form. So for those bright color, pixel, you can just represent by 1. And those are dark color pixel, you represent by 0. All right. So from this matrix, we can see the shape of the heads like this, right? Okay. But when the computer process, actually it process a string of binary, right? You won't see the H like human eye, but you will see a string of binary like this, right? So this is how we represent shape in number. And how to represent color in number. So color, we can use RGB. R stands for red color, G stands for green color, B stands for a blue color. So for any color, we can actually use a mix of these 3 color channels. So each color channel, we assign a number also, all right? For example, the blue color H here is represented by red channel with 68 intensity. It's called intensity value. Green with 114 and blue with 196. So the combination of these 2 channels give you this color. So in the software, actually in the Windows software, it gives you a template of color like this. So you just select any color, it will give you the number that it represents, right, from the 3 channels. So this is how we represent color in numbers. So how to represent picture in number? Same thing, right? Picture is actually composed of many pixels. So each pixel is a small cell like this with different color. So you can imagine each pixel or each cell has different color, and each color has 3 number, RGB number. So you can have a matrix like this. All right. Okay. So each cell will give you a color, and the combination of all these color will form you a picture. All right. So this is how we represent picture in number. So how to represent voice or sound in number? So we record the sound or voice, okay, in a sound wave like this. And actually, in a computer, it converts the sound wave, the loudness and amplitude of the sound into a wave like this, a graph like this. So when the computer read, actually it read this number of every time interval. Okay, so there is a sampling time. When you say something here, it will convert to a sample of different value. Okay, so you also can represent voice or sound in number. So you can see everything in the real world, whether it is sound, it is text, it is shape, it is color, or voice, or anything, it can represent in number. So this is how we can communicate with computer, and computer can process information. So this is another concept that you need to understand. In any in any machine learning, you will come across these 2 terms, whether it's a structured data or unstructured data. So any structured data, it must be in a table form like this. Very good example is Excel. All right. Have you used Excel before? Yes. All right. So Excel is a typical structured data, because when you key in the data, it's in the table form like this. If the data is not in a table form, it is called unstructured data. Example, video, sound, picture, and document. Like PDF document. PDF document, do you think is a structured or unstructured data? PDF. Unstructured. Yeah. Okay, correct. PDF is unstructured. Okay. All right. Everyone must have a quiz question. All right, I give to everyone. Do we have? So can you try to answer quiz 1? All right, you can just write down your name on the paper, and then you just tick the answer. We will check the answer later after we finish the section. Okay, please give a try. So the questions ask, which is the following example of structured data? A is PDF document, B is Word document, and C is a spreadsheet. Spreadsheet is the file format from Excel. Right? So which one is structured data? Okay. All right. Okay. We will discuss later. Okay. All right. Let's go to the next one. So far, any question about data? No. Okay. Great. And now you know you have learned. Okay. What is machine learning? So machine learning is a computation model that can actually extract information from data. All right. And what is data? Data is a number that represents text, video, sound, right? Any form of real world measurement. Okay. And all right. So now, what is the relationship between machine learning and data science? Have you heard about data science? The words. Okay. So data science, you know, machine learning learn from data, right? Human learn from experience, right? So how can we combine these two things? Right? Machine learn from data, human learn from experience. Data science, yes. Right. So data science is a science combine machine learning knowledge or information with human knowledge. Right? We learn from different ways. One learn from data, one learn from experience. So data science try to combine these two information or knowledge to achieve the best decision. Okay. So data science is a science of extract knowledge and insight from information learned from machine learning. So where is the insight come from? Insight come from human, because human learn from experience. Okay. The information come from machine learning. So human experience plus information from machine learning combined, we call it data science. Okay. Example. Here it is a problem of estimating the shop lot price. Example. Right? So this is data we have from the previous collection, right? Which consists of size, number of office room, whether the shop lot has been renovated. Okay. So this is a price. Okay. So from this pattern, actually machine learning can learn, okay, if the new property shop lot has this area size, have 4 number of room and renovated, what will be the price? Okay. So we use this data as an input to the machine learning to train it, and the machine learning will predict what is the price for this new property. And then as a human, then maybe if you are the agent, property agent, then you have to use your experience to judge whether this price is reasonable or not. Okay tak? Logic tak? Okay? Then you use your experience, right? So this, the information from machine learning is a guide to you to estimate the price. But the final decision still from you, right? So you need to give the insight whether the decision is correct or not. Okay, so this is an example of a data science. So now you know the relationship between machine learning and data science. You know about data already. Okay, how to do machine learning? So machine learning in general have 5 steps. So first step is asking the right question. Okay, example, based on your own job scope, for example, Wadi, can you give an example of your job?
Troubleshooting network.
Troubleshooting network. Okay, so troubleshooting network, for example, when you have a intruder, network intruder, atau kena hack your system kan, so you kena detect the hack from where, from mana. So you can use machine learning based on your network ID, all these things. Then you actually can simulate, right, to predict where is the hacker. All right, this is an example, right? So you must ask the right question, right? The question of what you asked just now is about how to identify the network, how to troubleshoot the network, right? And where is the problem? So problem can be, for example, hacked by some hacker, for example. All right. Then you have the problem statement, and your main output you want from machine learning is how to identify the source of hacker. Right. That will become your output. Then your input will be the network configuration information from everywhere, right? Okay. So first is start with asking the right question. So the question actually will address your problem that you want to solve. And second step is identifying, obtaining and preparing the right data. So machine learning learn from data. So data is very important, but data must be clean and good quality. Okay, machine learning learn from data, so it's rubbish in, rubbish out. If the data quality is not good, the output won't be good. All right. So make sure the data quality is good and clean. So there are many things you need to consider when you clean the data. First, of course, you check the data format, whether the format is correct or not. Second is whether they are missing data. And third, whether they are outliers. Okay? Outlier means something unusual, right? The data tiba-tiba out of range, for example. Right? So data have many noise, a lot of noise, right? Because the way you collect data from sensor, sometimes sensor have problem, right? So the data itself has a lot of noise. So second step is obtain a good and right data. And the third step is identifying and applying machine learning algorithm. So you need to choose the right machine learning model, right? So machine learning had two types, right? I mentioned just now. One is classification, one is regression. Okay, kalau you nak predict macam label is classification, you predict number is regression. So you have to choose the right model. And the fourth step is evaluating performance. Right? So lepas you dapat machine learning model, you kena evaluate, right? But whether the the model is accurate or not. Okay, kalau accurate you baru guna. Right? Kalau tak accurate, then you have to go back to the step 2, step 3 again. And you repeat the process until you feel satisfied and solve the problem. And yang kelima, last step is presentation of your model, maybe to your superior, to your boss. Okay, I have developed a model, then I want to implement in the real world, in the application, in the faculty operation, whether you approve or not. So you need to build a good presentation model, okay, to your superior or your manager. Okay, so far any questions? Boleh? Right? There are many ways we can build machine learning. You can start with a programming way. You can use any programming language. For example, Aziz, which programming language you know?
Laravel? Or from there?
Atau any programming, Java, C++?
SQL.
Okay.
SQL.
Hmm?
SQL.
SQL. Okay, SQL is more on that database.
Yes.
Okay. Anyone know about Python here? Tak ada kan? Okay. SQL ada kan? Okay. Tapi SQL pun boleh buat machine learning juga actually. Okay. Excel pun boleh. Excel actually ada built-in machine learning model. Macam regression model, you boleh dapat dari Excel. Tapi all this require programming skill. So yang today's we are going to learn is software without programming skill. That means anyone without programming background you can start straight away. So which is RapidMiner. So RapidMiner actually is quite popular in now. About 32.6% of users in machine learning use RapidMiner. Okay, so before we proceed with the use case, can you try on the quiz 2, right? On the paper I give you about the 5 step of the machine learning. So what you need to do is you letak number according to the order. Mana satu step 1, mana satu step 2. So ada 5 step. 1, 2, 3, 5, 4, 5. Okay. Okay, you will write itu number on the answer, right? Beside the answer. Okay, first is asking the right question. Then they have to clean data. Yes. Then choose the machine learning model, right? Then blah, blah, blah. Then another 2 steps. Finally, is present to your boss. Okay, manager to your. Okay. Shall we proceed? Okay, we will discuss later this question. Okay. Right. Now, can everyone execute the RapidMiner on your desktop? Okay. We have installed the RapidMiner software on your desktop already. So can you run the RapidMiner now? Okay. Now we have a quick introduction to RapidMiner first. All right. So RapidMiner is a software that allows you to build a machine learning model without coding. So dalam RapidMiner, there are more than 125 machine learning algorithm. Dah ada built-in lah, semua dah ada building. Dia tak perlu buat coding lagi. Okay. You just need to follow the 5 steps I mentioned just now. Okay. Everything is provided. So no need to do programming using Python, using SQL, whatever, no need. Right? It's very user-friendly. And they also provide more than 100 data cleaning and preparation functions, and over 30 charts of data visualization, which is a step number 5 that you require later to present to your superior or manager, right? To present your model, right? Through the visualization technique. All these are available all in one in RapidMiner software. And the way they program is very simple, right? You just choose the block, the right simulation, the function block, then connect, just sambung saja. Alright, so you just follow the 5 steps. First, ask the right question. Then you're going to define what is input, what is output. Then second, prepare the data kan. So you just choose the block for retrieve data, for example. Then the third is you clean the data. You tengok ada missing value tak, ada outlier tak, data semua in the right format tak. Semua dia ada tools dalam RapidMiner for you to clean and transform. So you can play, for example, this block, replace the missing data, for example. So what you need to do is you connect your data to this missing data block. It replace for you. Of course, you need to choose some parameter lah dalam ni. Then later you choose the model lah, the third step. And then final step is the performance, application, visualization, or you can connect later. So you can do the whole machine learning process just using connection of the block. Yeah? So no need programming. So I think you have done this step, already installed. So this software is free. There's a free version. And you need to register. Okay. So let's start with basic. I want to show you a video, introduction to the GUI of the RapidMiner.
Hello and welcome to this Getting Started with RapidMiner tutorial. In this tutorial, we take a quick look at our user interface. We'll talk about the operators, the repository, the process panel, the views, and the global search. We'll see the functionality of ports, parameters, and of course, we'll have a quick look at where to find help. But first, let's start with the different views. Once we open RapidMiner Studio, we end up in the design view. Next to it, there's the results view. Both views can be described as work areas which are equipped and optimized to carry out specific tasks as you undertake data prep, modeling, validation, and operationalization of your analytics processes. Next to the default views, you can find the option to start RapidMiner Auto Turbo Prep and RapidMiner Auto Model. Both are great to accelerate everything you want to do when building real data science solutions, no matter if you're just starting or if you're already an experienced data scientist. In the center of the design view, you can see the important process panel, which is used to design any process, for example, data loading, outlier detection, or forecasting. Processes are comprised of a set of connected operators, which can be understood as the building blocks. By default, the operators panel is open and placed in the bottom left. You can see the different areas in the operators panel called data access, blending, cleansing, modeling, and
straight away go to the hands-on. Okay, dalam Rapid Miner, this is called Rapid Miner Studio, right? So all the function in one page, very user friendly. Okay, so on the top here is called Navigate repository on the top left corner. Okay, you akan nampak ini. So ini is where you can import the data. All are here. So you actually you can save your data after you collect data, right? You can save in the folder of data folder, right? Under this repository data, you can import the data. The second menu here on the bottom left, ini adalah operators. So operator means the functional block in your Rapid Miner. Functional block means block untuk data cleaning, block untuk machine learning model, block untuk visualization. All these are called operator. Okay. So dalam operator, you have many choice here. You can find and search. So you just type the keywords here, then it will come out the block. So what you need to do is you can just select the block, right? Select the operator and drag to this empty space. Okay. So this is called process design window. So whatever your machine learning process yang 5 step itu, okay, you boleh implement in this space, in this window. Okay. Then this is the window for your parameters. So every block, every operator, there are some parameter you need to assign the value. So you can assign here. Okay. And this is the help menu. Help means kalau you tak faham atau the syntax, the functionality, how to use the block or how to use the operator, you boleh rujuk help menu. So you see, all are in one page, right? Then you can start doing the development for machine learning. Okay. Other than all this existing machine learning block already built in dalam Rapid Miner, kalau you nak something more advanced, which you tak dapat cari dalam Rapid Miner Studio, actually you boleh cari dekat Rapid Miner Marketplace. Okay. For example, there are many machine learning model developed in Python by many community. Okay, tapi mereka tak actually code dalam Rapid Miner. So you can find all these operator in the marketplace. Tapi some need to pay lah, some are free, but many are free actually. For example, web mining operator, text processing operator, Python's integration operator, and so on. All this you can find in Rapid Miner Marketplace. And you can build your own operator also. Kalau you nak macam for SQL programming. So if you find that okay, certain function tak ada dalam Rapid Miner, you boleh write your own code in SQL, then you just convert to Rapid Miner block. Then you boleh letak dalam Rapid Miner Marketplace untuk sharing. Atau you nak jual pun boleh, right? You can give a price, and those who are interested, they can pay you, right, to use your block. So this is called marketplace. Okay, so for starting, let us give a try, build a data from Excel file. So I have given you a 5 data file in your data folder. Okay, let's start step by step. So can everyone go to operator, you search for Excel. Yeah. So you can nampak with Excel sini, kan? So you just drag here. Okay. Yeah, read Excel. Okay, boleh dapat? Okay. So if you click on this block, okay, you akan nampak satu folder macam ni, iaitu specified from where you read the file. So I think all of you have saved your file in the data folder, kan? You go and check under data, you can dapat satu file, Excel file. Boleh? Okay, you keep open, dia akan masuk dalam. Okay, boleh? Okay, how to visualize the data you extract? Okay, you just drag here. Okay, nampak dia ada satu input, satu output dekat block tu. Dekat output ini, you drag to output terminal here. Okay, then you click on the play button on the left. You akan nampak satu table macam ni. So this is a structured data, kan? In table form. So in other words, you can actually save your data in Excel. Macam ni nak, kalau macam nak buat schedule maintenance prediction, so you boleh store your schedule maintenance data dalam Excel. Okay. Then you can read the data from the RapidMiner guna read Excel. Okay, this is the first way. So for whatever result you get output lah, you can click on the result button. Okay, kalau you nak balik pergi ke design mode just now, you just click on design. Dia akan balik ke sini. Okay, so you boleh switch result dengan design. Okay, so this is the first way of you can read data. Okay, I want to teach you the second way. Okay, so you boleh delete dulu. Okay, you boleh delete. Okay, the second way is you can download your data into your local repository. Ini macam disimpan dalam memory lah, dalam hard disk dulu, dalam your RAM dulu. So you can go to import, right? Import dekat sini. You click on my computer and go to the data file. Okay, just now you see Excel kan? Sekarang you pilih yang ada CSV, .csv. House price, data set. Okay, yang data yang sama tadi. Tadi in Excel format, sekarang in text form. So you go to next. Okay. So these are the data. It looks like. Okay. Mungkin sini saya akan give you another hints. So in machine learning, kita kena define, once you ask the question, you know the input and output, you kena define what is the output kan. So output normally we call it label, right? Sebab dalam table, data table, there are many column kan. So you kena define mana satu input, mana satu output. Because in any machine learning, you kena ada dua komponen, satu input, satu output. So output kita panggil label. So dalam kolom-kolom ini, you kena identify which one is label, your output. Others are input. So kalau you nak tukar jadi label, you boleh klik on this small arrow. Nampak tak? Let's say saya nak tukar ini stock price, the house price as a label. So saya boleh tukar change row. Then you boleh pilih label sini. Dia akan jadi as output. So dia akan color dengan green color. So it means all these are input and this is the output. Okay. Then you can go to next. You boleh save dalam directory yang sama. So dalam RapidMiner dia ada format sendiri so you can save dengan format dia. So you click finish. Yang akan nampak a similar table like Excel just now. Okay. So ini cara yang kedua. So apa beza yang tadi dengan Excel dengan cara ini? So the beza is this one is more efficient. Dia baca lebih cepat from the RAM. From Excel kalau data you besar sangat, is lambat. Okay. So if you have big data, better you use this second method. Tapi ini you kena RAM yang besar lah. Kalau RAM kena cukup lah, you punya RAM. Alright. Okay. So Now you already upload to your local repository. You akan nampak satu block yang blue color macam ni. Okay, yang you save tadi. Okay, so you just drag here. Dia akan keluar macam ni. So this is the block, the data you read from your local memory. Okay, boleh? So kalau you nak visualize, you just sambung the output to the terminal. You click play. Ia akan nampak table yang sama tadi. Okay, so this is the second step, right, in the machine learning, how you read data. Okay, so step 2, you kena clean data, kan? Kena check data dulu, betul tak, data quality okay tak? Okay, you boleh check dengan statistik dia. Okay, kalau ada missing data, ada value yang missing, dia akan tunjuk sini. So data ini nampak okay, kan? Tak ada missing data, so okay. Right? Then you kena tengok dia punya range. Apa range dia. Okay. And this is the average. Ini average penting untuk determine outliers. Okay, kalau ada outlier dia akan nampak. So untuk tengok ada outlier tak, you boleh plot data macam ni. Right, you boleh define you punya X. Okay. So you akan nampak data macam ni. Okay. So this you can use this graph to determine ada outlier tak, ada data yang tak normal tak. Right. Okay. And another thing is data type. Data type is very important because ada certain machine learning algorithm dia tak boleh proses nominal data type. Dia cuma boleh proses integer atau real number. Kalau dia formatnya tak betul, dia kena tukar. Baru boleh guna machine learning model itu. Alright. So yang data type juga important, you kena make sure. Nanti kita akan belajar ini semua step by step. Alright. So ini adalah cara untuk retrieve data. So ada question? Okay. Now kita proceed. Kita boleh delete ini dulu. Okay. Okay, kita proceed dengan satu simple konsep. Now kita nak belajar ada dua jenis machine learning kan. Satu ialah regression. Okay, regression untuk predict number atau value. Okay, classification, predict label atau name or class. Example, David, Ahmad, all these are called label. So this is budget, right, or a number. So kita start dengan regression model dulu sebagai satu case study. Belajar macam mana nak predict regression, guna regression model. Example untuk macam budget estimation. So this is an example of using regression. Okay, so ini ialah yang paling simple machine learning model untuk regression yang paling simple. It's called linear regression. Linear means what? Linear, lurus, satu garis, kan, lurus. So in a simple mathematics, you just draw one straight line. So dalam straight ini, you will buat satu equation yang simple lah, mx plus c. C ialah value ini ialah kecurunan dia. The gradient, we call it gradient. This is m. So you need to know the two parameter. So yang ini x ialah your punya input. Macam tadi punya house prediction, house price prediction kan. So input can be area and this is the price. So this is the output, this is the input. So from this line you can predict, okay? And ini ialah data yang you collect. You cuba cari satu line yang paling optimum yang boleh mewakili semua data ini. Right, the best representation of the data. Right? So kalau you have more than one input, right? For example, this example is about estimate the harga kereta, right? The car price. So ada dua variables ni, dua input sini. Satu ialah berapa umur kereta. Yang kedua ialah berapa mileage dia sudah jalan. So the more the mileage sudah jalan, the harga akan actually depreciate lah. Okay, and age also. Kan? So dia ada dua inputs sini. So bila nak predict harga kereta, you kena ada dua input. So you kena build dua linear model. Satu untuk umur, age, satu untuk mileage. Bila you dah ada dua model, then you combine sekali. Jadi satu equation. So bila you combine, dia akan jadi macam ni. Price equal to something, function of age, something function of mileage. So this is the result of combining two linear. So this is called multilinear regression. Multi means lebih daripada satu lah. Okay. So, okay, kita sekarang kita cuba satu exercise guna untuk house price prediction. So first step. Okay, so far boleh ikut Alright. So ask the right question, right? First step in machine learning. So what is the question here? The question is, you want to predict what? House price. Kan? So ini adalah data yang you collect. Sekarang you are interested, you ada minat untuk predict what is the house price for a new property. So your question is how to predict house price. So the sold price will be the label output. And your input will be all other parameters lah. Like berapa besar you punya rumah, number of bedrooms, number of bathroom, year the house was built, tax assess value, right? Okay, the value after the tax berapa harga. So all this actually akan decide you punya harga sekarang. Okay. So assuming now you dah ada data, you sudah collect data. And now you are interested to predict the new house price. So boleh guna teknik yang you belajar tadi, guna cara yang kedua, right? Yang cara kedua you read from the local memory, So you pergi import data. Okay, you pilih house price yang tadi sama, Yes. Okay. Sekarang you boleh set itu rows ke sini lah. Terus kalau you dah tahu you punya output mana satu, you boleh set sini terus. So you pergi ni chain row, dipilih label. Klik OK. Next. Okay, you save dalam folder yang sama. Nama you boleh kekal sama atau nak tukar, it's up to you. Dah ada satu data, dah read dalam memory lah. Okay. Sekarang ini step kedua retrieve data. Sekarang you kena clean data dulu, right? So, kena pergi tengok you punya statistik, tengok ada apa-apa yang tak normal tak. Okay. First you check ada missing value. Tak ada. Okay. Okay. Then data type. Semua integer kan, tak perlu tukar. So regression model no problem, boleh guna integer semua. So yang ketiga, ada outlier tak? Itu kita sekarang masih tak nampak. Nanti kita cuba dulu. Okay. Then you know this is your label kan? Ada color hijau ni. Green color means you sudah label lah. So yang lain ialah input, ini ialah output. Okay, semua okay? Go to design. Okay, now go to the step 3. Step 3 ialah identify, apply machine learning model. So you kena ada 3 steps ini. First, split training and testing. You pergi cari operator split data. Satu blok split data. Okay, in machine learning model, kita perlu ada prepare dua set data. Satu untuk training, satu untuk testing. So training ialah untuk train you punya machine learning model yang boleh buat prediction. But machine learning learn from data. So we need to prepare training data, kan? Lepas dia learn, kita kena test sama ada accurate atau tak accurate. So kita perlu data set yang berlainan. So training data dengan testing data tak boleh sama. Have to be different, tak boleh overlap. Okay, so dalam RapidMiner dia ada satu function yang boleh automatic split the data for you. Okay, so kita drag data dulu. Dah ada Okay, you cari split. Ada split data tak? Operator. Dekat sini. Dekat tempat ni. Okay. You tarik sambung sambung dua blok ini. Kalau you pergi split data, akan nampak satu menu macam ni kan. So you pergi edit, ini edit, akan come out satu table macam ni. So edit means you kena define berapa persen you punya data untuk training, berapa persen untuk testing. So sini you cuba letak 0.7 and 0.3. That means 70% akan split untuk training, 30% untuk. So you pergi add entry. First you key in untuk training ratio dulu So you letak 0.7. Then you add another entry. Okay. 0.3. Ini apa tak ada 0.7. Okay. Alright, akan nampak macam ni. Alright, then you click OK. So dia dah define lah. Itu block untuk dia dah split untuk you. Okay, apa step 3? Lagi. Sekarang pergi jadi kena select machine learning model. Okay, so you pergi operator again, you cari linear regression. You type linear. Okay, anda nampak ni linear. Okay, so you just drag and drop here. Okay, in RapidMiner Studio, kalau ada error, dia akan nampak satu red color sign macam ni. Okay, so in this case, kita belum sambung, that's why dia ada red color sini. So kalau disambung, dia akan disappear. So kalau sambungan tak betul atau data format tak betul, dia akan ada red signal there. Okay, then you boleh check semula apa yang ada problem. Okay, sekarang dah sambung. So you cuba tengok, pergi ke luar. Sila cuba check linear model itu okay tak. You pergi play. You akan nampak macam ni. Alright, so ini maksud dia. You pergi tengok annotation. Description. Ini ialah equation yang generate by your machine learning model. That means your house price equals to this number multiply house square feet plus this one plus this one plus this one. Ini ialah model yang RapidMiner learn from your data. Okay? So what is the next step? Kita dah pilih machine learning, kita sekarang nak test sama ada model itu okey atau tak okey kan. So you pergi apply, you cari apply dalam operator. Dia pergi design semula. Okey, ini buang dulu. Pergi apply. Nampak apply sini? Apply model, yes. Okay. So bila you apply, you kena masuk testing data. Sebab you sekarang nak test kan. So ada dua input kena define. So satu you sambung the model output sini. Ini model yang you train dengan train data. Then you kena test. So ini dia dah split. Satu untuk training, satu untuk testing. So yang second one untuk testing. Kita akan nampak macam ni. Okay. Alright. Boleh? Okay. So sekarang you nak check dia punya prediction. Semua okay tak ada red signal. So you click. Sekarang you nampak ada dua kolom yang hijau. Ini ialah yang label. Ini ialah machine learning punya prediction. So you check okay tak prediction dia? Ada yang okay kan? Agak quite close kan dia punya prediction. Okay, macam mana nak visualize sekarang? How to visualize? How to measure the performance? So kita pergi ke step number 4. Evaluation and adjusting regression performance. Okay, pergi operator, cari blok ini, performance. Okay, ada banyak kan? Pilih yang regression. Yang ni. Okay, you drop sini. Okay, you sambungkan yang output from the apply model tadi, pergi ke performance drop. Then ini keluar. Macam ni. Okay, you cuba klik output. Ini ialah performance dia. So it's called group mean square error. So apa yang kita nak ialah semakin kecil error semakin baik. Right? So this is a simple performance criteria. So you can check this indicator. You feel okay tak? Kalau feel okay, ini cukup accurate, then okay, you boleh apply this model. Kalau you feel that this not good enough, not achieve your expectation, then you boleh balik semula, pilih machine learning model yang lain, then you measure again until you find the best one you want. Alright. So kalau you nak tengok model dia, ini ialah you boleh sambung another output. This is I think the prediction output. Alright. Ini ialah output from your model yang dia predict based on testing data. Okay. So this is you can present this model to your manager, right? Okay, I have built this model and the performance is like this. Can we implement this model in our operation? Then you can discuss lah. Right? If your manager say, oh, this is not good enough, then you balik semula the step 2, step 3 again, pilih a machine learning model yang lebih baik until you get the result you want. Okay, so this is an exercise how to use regression model. So you can use this example, right, to build the budget estimation model, for example, to estimate maintenance price, for example, okay, and many other applications in your job. Okay. Okay, other question? Okay, we have built the first machine learning model. So please try quiz number 3. Okay. A linear regression can be used to so linear regression ialah untuk predict number. So mana satu yang predict number? First is predict stock, okay, stock index. B is whether the employee will quit or not. Is a yes or no, bukan number kan. And third is whether the boiler will fail. Itu bukan number kan, fail or not fail kan. So answer is stock price. Second question, what kind of equation can be represented by this chart? Ini bukan linear, bukan linear. So yeah, curve. So mana satu? Okay, for hints, logistik ialah untuk classification, bukan untuk regression. Ini you belum belajar lagi. Nanti the next exercise akan guna ini. Okay, so the answer is polynomial. Okay, polynomial boleh untuk lukis curve, untuk represent curve. Okay, so are you boleh ikut So are you ready for the next use case? Kita sambung So next use case is about classification. You learn the second type of machine learning, classification. So apa question yang actually highlight sini? First step, asking the right question. What is the question here? Alright, so scenario ni macam ni. You are an online merchant. You buat satu online business. You dah build satu website untuk buat online business, e-commerce lah. So you are very interested to know your sales. You want to identify the prospect customer, kan? So ada banyak inquiry from to your website. So you want to know which customer yang ada potential akan beli your punya product. So this is a question. You want to estimate whether the sales will be yes or no. Yes, then akan beli. No mean tak beli. So what is your input? So this is the information you collect from your website, from the customer. Unique ID, berapa lama dia dah engage dengan you punya commerce, user age, city, from which country, which browser they use, source of traffic, and so on. So, yang penting kita dah identify lah, kita nak ini sebagai label. Did he, she buy a product from you, from your website? So this will become the label. So this is a classification problem because you just want to know what is yes or no, kan? So bukan number. Okay, second step. Retrieve the data. Okay, boleh you pergi yang design semula tadi, you clean. Kalau you nak save pun boleh, you pergi file, save process. Okay, then you boleh save you punya proses dalam folder process. Kalau you save dalam ini, then later you can recall back lah, you boleh retrieve balik. Kalau you nak study again the model.
Same name?
You can put any name, tak apa. Yeah. Okay. After you save, then you close lah. Then you go to file, new process, just blank. Dah save, then tak apa lah. Okay, you blank again. Okay, step pertama. Let's try. Retrieve data. Pergi import. So sekarang you pilih, anda nampak predict prospect tak? Ni. Ada. Okay. Just select. Okay. Itu set row jangan buat dulu. Saya akan tunjuk satu cara lain untuk set row nanti. So you just click and save. Finish. So yang nampak macam ni Okay. Okay, sekarang kita pergi set number 2 Okay. Sekarang you inspect you punya data dulu sama ada date formatnya betul tak? Okay, missing. Ada satu missing kan. So ini you kena deal nanti. First is missing. Second, you check the type, data type. Untuk data type, regression model you kena tukar sebab regression tak boleh deal with nominal. Nominal is name. So kena tukar menjadi numbers. So ada berapa nominal here? Ada GUID, city, country, browser. So kita ada a few lah. So dan GUID ini not useful actually. Sebab GUID memang berbeza untuk semua customers. So it is not a useful information. So later kita akan remove GUID. Yang kedua, yang kena remove ialah sale value. Sebab kita tak nak buat regression di sini. Dan not interested in the value you sell. Kita cuma interested whether you want to buy or not. So ini kita akan remove juga. So missing value under which variable, which age. So age you kena tengok berapa persen. So kalau less than 20%, then you can cuba replace lah with some technique. Kalau more than 20%, normally we just remove. Sebab you replace, dia akan tak accurate. Terlalu banyak missing. So less than 20%, you still can keep, no problem. So in this case, we will keep. Right? So we have to deal with this later. So we do one by one. Kita start dengan convert nominal to numerical dulu. So kita kena convert browser, traffic source, country and city. So pergi design, you cari nominal. Ada nampak nominal to numerical? Okay. Oh sorry, you kena ini retrieve dulu, kena ada data dulu. Yes. Data dulu. Dah ada? Itu dah ada data, okay. Alright, kemudian you pergi nominal to numerical. Okay, then you link. Okay, apa yang kita nak tukar dulu? Browser. Okay, so you can actually rename. You right click. You boleh rename. You just tulis browser lah untuk just label. Supaya you tahulah you dah tukarnya. Okay. So browser. Sekarang kita try. You pergi attribute. You select single. Single means kita pilih satu attribute saja. So you boleh pilih browser. Okay, then you tukar ini jadi unique integer. Okay. Kita mau nak present, for example, Explorer. Okay, kita use Zillow to wakil Explorer. Then we use Fox what? Mozilla. And Mozilla kita assign 1 to represent Mozilla, and 2 for maybe Edge browser, and so on lah. You guna integer to represent a different browser. So it's called unique integer. Okay, so kita dah siap ini. So kalau you nak check sama ada betul tak, you go to the ini, you boleh play semula, you kena check browser punya column, dia dah tukar lah. Tengok jadi 0110. Okay. Okay. So dia dah tukar integer. So bila pergi statistik, browser dah jadi numerical. Then okay, right? Regression boleh proses. Okay, so now go to the next one. Traffic source. So you buat the same thing. You cari nominal again. Then you rename traffic source. Okay, you sambung. Okay, pilih single. Pilih traffic source. Unique integer. Okay, sambung. Check semula. Okay, tengok traffic source dah jadi integer. Okay. Okay, so ini kena pilih traffic source.
Oh, sini. Oh.
Okay. Okay, you repeat untuk country. You buat sendiri country dengan city. So you sambung 2 blok lagi. City. Okay. Kalau you dah siap semua, dia akan nampak macam ni. Semua dah tukar jadi integer. Okay, country, city saya kat sebelum siap city. Ini jangan lupa kena tukar unique integer. Ini juga unique integer. Okay, semua unique integer. Okay, so ia akan nampak macam ni. Okay, right. So sekarang ini kita dah siap. Type kita dah okay. Ada satu lagi, set row itu nanti So sekarang kita pergi the next step. Replace missing value. Okay, yang ni. So kita ada missing value untuk age. So you pergi missing value, you cari replace missing value operator. Ada, okay, saya akan ini, okay. Dia ada 2 tapi dia replace missing value. So ini you rename. You letak age. So you sambung sini ke sini. Kalau tak cukup, you boleh drag sikit. Okay, so kalau you klik replace, you pergi single, you pilih age. Sebab you nak replace age, ada 129 missing value. So you boleh pilih cara yang berlainan under. So here it means you replace with average lah, macam dia ada age, kan? Let's say number 1 is 29, this one missing. Number 3 is 19, 4 is missing, 5 is 30. So dia akan pilih the average lah. So average will be 19 plus 30 divided by 3. So dia akan masukkan value ini untuk semua missing. Okay. So kita pilih average sini. Dia ada cara lain tapi you pilih average. Okay, so you cuba sambung. And you play. You nampak age dia. So you pergi statistik. So sudah tak ada missing value, kan? You check age. Dah kosong missing value. Okay? So ini step dah okay. Okay. Step yang sekarang kita kena set row dulu. Tadi kita tak ada set row, sekarang kita set row. Okay, sebelum kita set row, kita kena tukar numerical jadi binomial. Sebab ini ialah bukan number, dia classification. So, kena set jadi nominal. So, you pergi design. Okay, you type numerical. Anda nampak tak? Numerical to binomial. Okay, sambung sini. Numerical to binomial. So kita nak set sales jadi binomial. Binomial mean true or false, right? Yes or no. So you click this one. You select single. Select sale. Ini extra step you kena careful, kena select ini. Special character. Sebab dia label, right? Dia bukan attribute. Bukan input, dia output. So that's why you must select as a special character. So if the attribute is output or label, you must tick special character. Ini. Okay? Ini penting. Kalau tak klik ini nanti ada error. Okay? You select sale. Okay, then you try to check. Okay, you check semula sama ada dah tukar tak. Okay, saya tengok dia ada dah tukar false true kan. So dia dah jadi binomial. Okay. Alright. Ada tak nampak ni? Sales. Okay, semua ada? Ada. True dia tak banyak. Tak banyak. Yang paling bawah. Okay. Alright, kita dah tukar semua type. So ini dah settle. Now pergi ke set row now. You cari set row. You type set row. Ada nampak set row? Okay, set row kita nak set output. So, dia tarik. Sambung. Okay, so pergi pilih. You pilih sale. Then, label. Ya, set row. You pergi edit. Okay, set cell and label. So there are two way. Ini ialah cara yang kedua. You boleh set row. Cara yang pertama you set dari bila you read data. Okay. Ini cara yang kedua. Then you apply. Okay, you nak check semula, you pergi output semula, tengok dia dah tukar tak. You kan nampak green column macam ni. Dia dah set lah. The row sudah set. Boleh. Kita ada last step lagi. So set row dah settle. Ada satu step lagi, remove. Okay, macam mana kita nak remove kolom yang tak guna? So kita sekarang nak remove GUID and cell value that is not relevant. So kita pergi ke ini, dia pergi cari select attribute ni. Okay, select attribute, you tarik. Okay, sambung. So tadi terlupa rename. You rename sendiri ni. Dari sales. Okay, yang ni sales juga. Okay, sekarang kita nak remove which one? GUID kan? So pergi, kita nak buang kan? So nak exclude. Okay, so dalam type ini you pilih exclude. Sebab kita nak buang, nak remove. Then you select GUID. One attribute. GUID. So then you rename this as GUID remove. Remove GUID. Alright. Okay, kita dah buang satu, kita ada satu lagi cell value kita nak buang. So you repeat semula. Sambung. You pilih exclude. Okay. One value. Cell value. So ini untuk cell value. Yep. Sorry, ini untuk GUID. Cell value. Dah. Cell value. Yes. Ini untuk cell value. Okay. So, you check semula, tengok dah buang tak. Yang nampak, itu cell value dah hilang. Itu apa? GUID pun dah hilang. Okay, ini yang data yang clean lah. Yang dah okay. Dah boleh pilih machine learning now. Okay. Okay, semua dah okay? Okay, kita proceed dengan pilih machine learning. Okay, sebelum itu saya nak ajar satu teknik lagi untuk, ini nampak messy kan? Banyak block kan? So you boleh buat macam ni. Okay, you pilih yang ini semua. You right click. Ada nampak move to sub process. Okay, you klik ini. Okay, dia akan string So now you rename. Dia boleh buat letak data pre-processing. Oh, data processing pun boleh. So kalau you nak tengok detail, you boleh klik, dia akan explode lah. Kalau you nak simpan, double klik saja. Dia akan simpan. Dia nampak lebih tidy lah, lebih neat lah. Dia akan messy sangat. Okay, dah okay? Dia akan keluar detail semua. So kalau balik semula, you just click on process. Okay, dah ready? So sekarang kita pergi step number 3, select machine learning. Step yang sama, split training testing. Okay, pergi split data, sambung. Okay, guna percentage yang sama. Edit, add 0.7, 0.3. Okay. Okay. Dah split data. Okay, now pergi select. Okay, ini untuk try, you boleh pilih machine learning berlainan atau apa. You pilih logistic regression. Try logistic regression. So pergi cari logistic regression. Anda nampak? Okay, sambung. Ada error. Ada error tak? Tak ada. Saya ada error. Oh, saya terlupa ni. Okay. Yeah. Alright. Okay, right. Cuba tengok boleh keluar tak? Kalau okay, dia akan keluar model macam ni Right, ini adalah logistic equation. So tak apa, kita pergi proceed dulu. Okay, sekarang kena apply sama step apply. Yes, kita dah train kan, so kena apply. Apply, sambung. Okay, apply, you tarik bawah sikit sebab you kena input from the testing. Yeah, so ingat apply selalu ada dua input, satu from the model, satu from the testing. Yeah, ada dua input. Dia apply model, you boleh terus tengok dia ada keluar tak. Dia kan keluar macam ni. So tengok dia punya prediction. Ini yang label you from test data, ini yang prediction. So kalau prediction betul, dia akan sama. Okay, that means your model is accurate lah kalau prediction sama dengan label. Alright, so yang apa kolom ini? Yang ini. Ini ialah confidence level. Okay, so bila you buat prediction, machine learning, okay, dia akan define confidence. Berapa confident dia prediction dia. So ini semua satu, tengok. Okay, prediction ini untuk true, itu false. False mean tak beli lah. Right, so yang ni true. So ini prediction false, label false. So confidence-nya 1. 1 mean 100%. So, you tengok ada confidence yang lebih rendah sikitnya, 0.99 pun ada, 0.95. So, kalau prediction dia sangat rendah, confident, actually you boleh retrain the model again. Alright. It gives you some idea whether your model okay tak performance. Kalau okay, selalu confidence dia akan very high. Okay. So, next step. Evaluation. Okay, kita cari performance. Okay, sekarang you kena pilih, tadi aggregation kan, sekarang kena pilih classification. Classification. Alright. So, you can sambung dari model, apply, terus keluar sini. Okay, macam mana kita measure performance untuk classification? Untuk regression kita guna root mean square error. Tapi untuk classification dia lain sikit. Dia guna confusion matrix. Confusion matrix means kalau label dia true, dia predict true. That means true positive. Kalau dia label dia true, dia predict false, that means is the false positive. Right? So yang penting ialah yang ini yang kita nak maximize. True positive dengan true negative. Okay, the higher the better. So kalau model you bagus, ini akan very high value lah. 90. Okay. Kalau low value, then you kena adjust semula you punya model. Atau guna model yang lain. Machine learning model yang lain. So ini cara kita measure the performance untuk classification. Okay, macam ni. So yang penting ialah true negative dengan true positive as high as possible. Okay, okay, right. Okay, so that's then you can present right to your manager or to your customer. Okay, so that is about classification. So classification you boleh predict macam untuk predict maintenance. Okay, machine itu sama ada perlu maintain atau tak maintain. So you boleh set classification problem macam ni. Kalau perlu maintain dia akan true. Tak perlu maintain false. So the data could be berapa lifespan dia, you punya bearing, you punya spare part dah guna berapa lama. Kan? All this can be the input. Okay, kalau ada masa sikit, you pergi try quiz number 4. So classification model can be used to predict what? Price ialah number atau bukan number? Number kan? Number ialah regression kan, bukan classification. Okay, predict an employer who will be quick. Okay. Yang ketiga, predict temperature. Temperature number ke? Number kan? So yang answer dia? Boleh? Senyum saja. Boleh? Okay. Okay. So answer is B. Okay, yang ketiga ini cuba try. I can use classification model to predict label that has 3 value. Example, cat, dog, sheep. Inilah classification, different label. Boleh tak? Boleh kan? Okay. You just set the label for different number lah. Okay, so itu saja for classification. Kita ada 2 use case lagi. Satu clustering, satu untuk anomaly detection. Okay, kita akan habiskan. So boleh kita break 5 minutes. Nak minum, nak pergi tandas. Okay. Kita balik semula 11:40. Okay. So welcome back to the second section. So now kita akan belajar tentang clustering. So clustering is a type of unsupervised learning. So dalam machine learning ada dua jenis. Okay, other than machine learning, dia ada dua jenis. One is called unsupervised. Satu lagi is called supervised. So yang supervised yang you belajar tadi, one is called regression. Ini untuk value, kan? So yang classification, ini untuk label. Okay. Supervised mean dia ada label lah. Kalau data tak ada label, it means dia unsupervised. Dia boleh guna unsupervised. Okay. Okay, so dalam application ini, kita akan belajar clustering. So clustering is unsupervised learning. So background ni macam ni. So macam kita punya Medical Center, UMMC, ada banyak patient kan. So what is our problem? Our problem is parking tak cukup, kan? Doktor tak cukup, patient terlalu banyak. So patient kena queue kan, setiap hari kena penuh. So why this problem happen? Because banyak patient just walk in saja, kan? Sama ada critical tak critical, semua walk in. So bila walk in, kita kena entertain, kena bagi queue number. So that's why it cause some congestion dalam clinical service. So how to solve this problem? Kalau kita boleh prioritize mana patient yang critical, yang high risk, dan mana patient yang low risk, then kita boleh schedule. Okay. So yang high risk kita akan bagi appointment dulu. High risk. Ini ada condition yang critical lah. Yang low risk mungkin boleh tunda ataupun dia boleh monitor from home. Kita sekarang ada telemedicine kan, all these things. So this is the about this data. So this data is a patient data. So kita ambil ni punya data macam age, body weight, waist size, kan? Apa lagi? Blood pressure and so on. So this data kita. Okay, so here we actually use a few attribute yang penting lah, yang selalu doktor boleh guna untuk preliminary diagnosis. For example, yang those yang overweight, for example, obese, waist size dia akan lebih besar kan. So kita boleh prioritize based on the weight, for example, or based on the waist size. So because waist size is correlate to cardio disease, kan, the chances of having cardio disease, orang yang obese atau waist size dia besar, risk dia akan tinggi. For example, right? So what is the clustering? So satu teknik yang kita akan belajar sini ialah K-mean clustering. Inilah name of the clustering method, K-means. K-means you need to set the value K. K is a number of cluster. Okay, macam let's say I give you an example. Sini ada dua pattern data. Saya tak tahu label dia lah. So from your view, you rasa ini berapa cluster? This one ada berapa cluster? Cluster ni berapa group? Kan? Ini kita boleh group, ini boleh group kan? So ada dua. Sebab dia tak ada label, so kita cuma boleh guess dari segi similarity dia. Yang sama, yang pattern dia sama, dia akan group together. Alright, so that's why we call it clustering. So in K-mean clustering, kita ada data macam ni. Alright, tak ada label. So kita start dulu dengan kita make a guess. For example, kalau kita nak cluster macam high risk patient dengan low risk patient. So yang kita interested ialah dua cluster saja kan. Satu cluster yang high risk, satu cluster yang low risk. So kita boleh tak K equals to 2. Okay, for our problem. So kalau data macam ni, kita can randomly put a point or centroid, we call it centroid point, anywhere in the data space. So macam for this case, for example, kita letak ini adalah data, ini yang dua centroid yang kita randomly letak from the beginning. So kita boleh draw satu boundary yang equal distance. Okay? So this is the first step in K-mean. Then kita measure berapa distance from each point ini, yang data yang kita ada, to cluster 1. And berapa distance ni, berapa jauh dari cluster 2. Kita measure. Okay. Then kemudian kita take the average of the distance. Kita adjust itu position dia. Position ini mula-mula is random kan, mungkin tak tepat. So lepas kita calculate average distance from every point yang closer to this one, kita akan assign the position yang baru. So bila position yang baru, ia akan lebih dekat dengan group dia. Okay, so it's just like, you know, you try to find the centroid, centroid of gravity untuk setiap group. So you repeat the same process, repeat, calculate again, repeat. Dia akan converge macam ni. Right? So at the end, dia akan dapat satu centroid yang boleh mewakili all the data here. And another centroid wakili all the data here. So ada dua centroid lah. So dua centroid mewakili dua cluster. So satu cluster untuk high risk, satu cluster untuk low risk patient. So yang ini ialah patient data lah yang kita boleh guna ini. So bila ada satu patient yang baru, data dia masuk, dia akan measure, okay, lebih dekat ke ini ke atau lebih dekat ke yang ni. So kalau dekat yang merah ni, mungkin represent high risk patient. Kalau lebih dekat daripada yang biru, then it is a low risk patient. So kita boleh segment, it's called segmentation. Dari semua patient kita boleh segment into two group. One is high risk, one is low risk. So ini senang untuk doktor lah buat priority, nak buat appointment untuk siapa dulu. So give priority to those high risk patient dulu. So ini story dia tentang problem ini. So the first is ask the right question. So the question is how to segment the patient into high risk and low risk patient. Okay, then kita start step number 2. So step number 2 is retrieve data. You boleh repeat process. You cuba retrieve data dengan name, file name ini, patient plus data. Pergi import. You pilih, ada dua sini ya, you pilih yang patient plus data, plus new, that one akan guna later. Data. Yes. So ini tak perlu change row, tak perlu set row sebab ini unsupervised, tak ada label. Okay, so you just click finish. Okay, save dalam ini. Okay, you nampak macam ni, data dia. Okay, so K-means, untuk K-mean method, semua data perlu must be numerical. So first step, you kena tukar nominal to numerical. Ini requirement dia untuk K-mean method. Okay, apa lagi? So yang nominal mana satu? Gender. So ini kena tukar. Okay, second step. Ada missing data tak? Tak ada. Okay. bagaimana dengan data range dia. So untuk clustering macam K-mean, lebih baik kita normalize range jadi sama. Sebab kita ada range untuk macam height kan. Height dia average macam 68 saja. Tapi untuk weight 200 something. So dia punya range macam tak seragam. Satu yang besar, satu kecil. So untuk clustering lebih baik kita selalu normalize to the same scale. Right? So normally normalize between 0 to 1. That is the best practice lah. Right? The value must all between 0 to 1. So that range is sama. So nanti kita akan buat normalization. Kita guna Z transform. Okay? Untuk semua data. Right? Okay, kita start dulu, retrieve data. Then, tukar nominal to numerical. Okay, akan nampak macam ni. Alright. Nominal to numerical Okay, you sambung. Then you rename. Ini gender. Okay, so you check. You pergi select gender, single gender. Okay, you change guna dummy dummy. Okay, dummy macam ni. Kalau unique representation, dia guna female, male kan. So female dia guna 1, male guna 0. Example. So it is a unique. Kalau guna dummy, dia macam ni. Ini guna 0, 1. Ini guna 1, 0. Dia jadi binary. Dia akan 2. Okay. So cuba you select dummy. Select dummy. Dummy coding. Okay, you tengok. Okay, dia akan nampak macam ni. So dia akan jadi 2 kolom. Satu kolom semua 1 untuk male, 1 untuk 0. Dia tambah high column tak? Yes. It depend. Sebab ini untuk clustering, kita nak semua range 0 to 1. So that's why kita guna dummy. Sebab dia akan automatic jadi 0 or 1. Okay. So ini dah done. Alright. Okay semua? Boleh Okay. Okay, next step. Kita pergi normalization. So ini formula untuk Z transform yang kita cuba normalize. There are many normalization method. Tapi untuk exercise ini kita pilih Z transform. Ini formula dia. Okay, so you pergi ke normalization, you cari normalization block. Okay. Okay, you cuba run tengok. Dia akan jadi number macam ni. Akan pelik sikit lah sebab dia ada negatif kan. Tak apa, you just leave it there. Right? Sebab dia guna Z transform. Dia ada mungkin boleh jadi negatif. Okay. So sekarang dah okay, semua dah number. Tak ada nominal lagi. Alright, so the next step is kena kita tak perlu split data in fact. Kita kena retrieve satu data lagi. Okay, ni dah salah, ni tak perlu. Okay. So, kita perlu retrieve satu data lagi. Okay, you pergi ke import data, computer, you retrieve another data called patient data plus new. Okay, akan nampak data macam ni. So, inilah data dari new patient. So, nampak weight dia, right? All these are weight dia besar. So, most likely this patient will be high risk. Sebab weight, overweight, right? Okay, and waist size dia juga besar. Right? So, kita simpan dulu data ini. Okay. Okay, now kita cuba pilih clustering. Apply machine learning. You pilih k-means. You cari clustering. Clustering. Clustering ada k-means kan? K-means. Pilih k-means. K-means lah. Yang pertama, yang first one. Okay, so k-means. Okay, you click on k-means, clustering. Nampak K kat K sini. So K kita interested on 2 cluster saja. High risk, low risk. So tukar jadi 2. Okay, K2, right? You cuba run. Okay, so dia akan nampak ada 2 clusters ni. Satu cluster represent high risk, satu cluster represent low risk. So cluster 0 ini high risk lah sebab weightnya lebih tinggi, right, compare to low risk. Okay. Okay, sekarang kita nak test. Dia cari apply. Okay, sama you sambung clustering output masuk sini. Okay, then you pergi ke patient data new tadi yang you retrieve tadi. Ada? Yang tadi you retrieve. Okay, you sambung terus ni. So in unsupervised learning, you tak perlu split data sebab dia tak ada label. Okay, so you just need to get new data directly masuk macam ni. Okay. Okay, cuba tengok output. Semua dia cluster as high risk. Ini data patient baru. So patient yang baru semua high risk.
Untuk data baru saja.
Yes.
Lama tadi tak?
Tak perlu. Sebab central you dah dapat. So central akan mewakili semua training. So cuba simpan central value saja. So data baru masuk, dia measure mana lebih dekat. Yang dekat itu ialah label dia. Yang high risk lah. So we use this method to segment patient. You can keep segment new patient using this method. Okay, so this is a result that you can present later, right? Yang you dah build tadi. Yang ni. Okay, so you can just present this table. If your manager asks or the doctor asks why you think that patient number 1 is high risk, because the height is this value, weight is this value, right? There are some criteria in medical, right? Overweight ke, obesity ke, the BMI ke, semua boleh go measure. You boleh explain why you choose this patient as high risk. Okay. Itu saja So this is about clustering, how you segment patient. So what is the application in your operation, in your job? For example, you boleh segment student yang selalu tak hadir kelas, for example. Yang student yang B40, for example. So based on family income, you boleh buat segmentation macam ni. Boleh identify which student are group B40, which example. Okay. You even boleh segment, okay, untuk maintenance. Mana satu spare part yang, how to say, kalau nak pilih vendor, for example, this spare part buy from many vendor kan, based on the previous transaction, you boleh segment, okay, which vendor yang will be the high priority untuk tender, for example. Example. Banyak boleh buat. Okay. Boleh sample high risk vendor, low risk vendor. Okay. So quiz itu you cuba buat tadi. What is unsupervised learning? Tadi saya dah bagi kan. Unsupervised learning tak ada label. So K-means boleh proses nominal data tak? Tadi. Yang tadi kita pernah ada tukar kan nominal tu. Yes. So tak boleh. Tak boleh proses. So this is false. So kena tukar dulu all the nominal data jadi numerical. Okay, anomaly. This is our last. Hopefully kita boleh habis sebelum 12:30. Dah cukup 3 jam. Cukup. So kita kena nanti boleh buat sikit discussion lah, extend. For 3 hours until what time? 1. Okay. Kita slow sikit. Alright. Alright. So anomaly. Okay, example. So sekarang, who is the richest man in the world? Tahu tak? Tesla. Betul, Tesla punya bos. Elon Musk. Siapa yang faster man, yang run faster? Dari Jamaica tu. Ini dua ni. Okay, Usain Bolt and Elon Musk. Okay, why they are special? Kita cuma ada satu in the world, like the richest kan, satu the faster kan. That's why they are abnormal. Abnormal means special, or outstanding, or it can be a good sense or bad sense, depend. Kalau dari segi data, mungkin dia tak, it's not good. Okay? If you have too much outlier in your data model, dia akan affect your accuracy. Some important application use anomaly detection, macam, okay, this is example. Anomaly bad for regression. That's why during the what you call the regression problem, semasa you buat data cleaning, you kena actually buat the outlier detection dulu. So, ya data yang outlier itu you kena buang dulu. Tapi you kena ada kriteria untuk measure lah, which is outlier, which is not outlier. So, example macam ni, outlier, dia ada dua sini. So, bila you try to build the model, dia akan macam effect sikit lah, dia akan tarik line ini lebih sini. Kalau you buang dua ini, dia akan lebih cantik, dia punya regression model. More accurate. Alright. yang kena buang. So anomaly are bad for regression. Okay. So can we spend a bit 5 minutes? You write down on the paper. What is the application of anomaly detection in, for example, FSCIT in your job? Maintenance. Maintenance itu kira apa? Anomaly detection juga. Predictive maintenance kan. You nak predict abnormal. Macam aircon. So bila nak buat maintenance. So you boleh measure dia punya apa? Temperature, stability. Okay, or dia punya current stability. Example. Network, like the network network maintenance kan. Intruder detection yang hacker itu semua. So you kena ada satu log file untuk you punya network activity yang normal. Alright. So kalau normal pattern dia akan konsisten. Kalau ada hacker tiba-tiba, dia akan create some abnormality dalam pattern dia. Right? So you boleh guna abnormality detection untuk hacker detection, for example. So untuk network, untuk telekom network, nak identify customer siapa yang akan terminate contract, for example. Right? So it's called abnormal detection also. Kalau lama tak bayar bill, for example, it's abnormal kan. Semua customer bayar, dia yang tak bayar. So anomaly detection. So telekom boleh guna anomaly detection untuk detect siapa customer yang akan potential jadi terminate. Example. Finance, credit card fraud, fraud detection. Yang activity yang suspicious. So you boleh based on the card activity and detect fraud itu berlaku atau tak. Okay, so it's called fraud detection. Ini juga guna anomaly detection. Insurance, insurance companies also can identify which customer will not pay the policy. Also you identify abnormal customer. Manufacturing, yang itu saya bagi example tadi. For example, bearing failure. Yang machine, bearing itu dia ada lifespan kan. So bila you monitor dia punya vibration, acceleration, you akan nampak dia pattern dia. Kalau bearing tu sudah start nak rosak, pattern dia akan ada spike banyak dari segi acceleration dia atau vibration dia. So from the pattern, you can identify anomaly. So bila anomaly happen, dia tak akan rosak terus, tapi dia akan mungkin predict to be rosak, I think within certain time. So you can predict, okay, it will spoil like in 2 weeks time, 3 weeks time. So dia boleh flag lah to your maintenance team. Oh, this bearing going to fail in 2 weeks. So kena beli sekarang bearing yang baru. Standby lah, bearing kena order kan. So machine itu takkan down either. Because when it's down, or you can replace early before they down. So dia takkan affect your production. So normally in production line kita ada redundant machine. So kalau line ini nak maintain, line yang kedua akan replace. So the whole line will be down, but second line will replace the operation. So dia akan interval, you boleh buat scheduling untuk maintenance so that the production won't stop. So factory they can't stop the production kan. So because business, right, dia profit dia akan loss kan kalau tak ada production. IT and security, intrusion detection, network outreach. Example. Okay, routing. Routing also important. Kalau bila you nak design load distribution untuk dia router, then you boleh predict lah mana satu peak hour, in which zone, under what time. So normally peak hour is like maybe during the class peak hour kan. The either time maybe during lunch time atau after off the hour. So you boleh reschedule you punya router punya load. Which one want to allocate more to bandwidth. Okay, actually our macam data line actually telekom mereka ada load optimization. Because not all the subscriber using data line all the time. Walaupun kita subscribe package yang sama, tapi orang ada yang guna lebih, ada guna yang kurang. So dia boleh macam offset lah. Yang tak guna boleh bagi yang guna. So you boleh optimize, kan? Alright, so how to measure the outliers? Okay, so the outliers based on this one of the methods called distance based method. The idea is very simple. Inilah data yang you ada, kan? Yang normal. Ini red color dot ini ialah data yang tak normal. So kalau dia tak normal, dia akan jadi outliers. So outlier means distance dia dari yang normal itu akan jauh, lebih besar. So bagaimana you measure distance dia? So one of the simple method kita guna Euclidean distance. Formula macam ni, right? So you boleh extend untuk more than 2 dimension lah. Ini ya example untuk 2D. You boleh tambah 3D lah. 4D tak ada masalah. So you just measure like this. So kalau data you banyak dimension, banyak attribute, tak apa, you boleh keep adding, and then you take the root mean square error, the root mean square. This is known as Euclidean distance. So kalau Euclidean distance dia besar sangat, you set a threshold. Kalau more than the threshold, then you identify this is outlier. Less than the threshold, then normal. So the challenge is in anomaly detection, susah nak kumpul data yang tak normal. Sebab selalu data kita expect to be normal. Right? So we have a lot of normal data, tapi data yang tak normal susah nak dapat. Okay, so the challenge is we don't have not enough data for abnormal. So kita tak boleh buat supervised learning sebab data tak balance. Semua data cuma normal saja, a few only normal. So bila buat training, dia akan imbalance. So bila buat supervised learning, very important you must have a balanced data. Kalau data tak balance, you akan either you have to make the data balance. Okay, you gonna think of a method to make the data balance. Data balance mean semua class punya label ada almost equal number of sample. Tapi untuk anomaly detection, this is not common. Susah nak dapat data untuk abnormal. So normally data is not balanced. So tak boleh pakai supervised learning. Not common lah. Tak sesuai pakai supervised learning. So kena pakai method macam ni. Tak perlu label. Measure distance saja. Okay, so this is a case study lah. Predict the boiler failure using anomaly detection. So kita ada satu boiler, assuming dalam factory. Dalam boiler ini kita ada measure 2 sensor. Satu untuk temperature, satu untuk pressure. So very important because the boiler dia ada operation range. Normal operation range. So kita tak nak boiler itu overheat. Okay. So you ada operation range untuk temperature, ada satu maximum value, satu minimum value, and you ada satu pressure. Okay. Satu maximum, satu minimum. So very important. Very important. So kalau operation dia selalu dalam normal range, that means tak perlu maintenance. So masalah dia, kita kena trigger bila temperature out of the range in advance. Kena alert. So that is the problem of this scenario. The question is how to detect anomaly in either pressure or temperature for a boiler. Okay. Kita ada data. So data dia senang saja. Dual reading, temperature and pressure. So boleh pergi ke proses. You create a new process. Okay, import. Okay, I pilih boiler. Blankkan tadi, blankkan tadi. Kalau nak save, you save dulu. Alright, so akan nampak data macam ni. So, you see one reading for temperature, one reading for pressure. Yang ini ialah boiler punya ID. Boiler 1, boiler 2, so on. Okay, senang kan? So normalization. So normalization also important for anomaly detection. Sebab senang sikit kita set dia punya threshold data. So kita tak perlu sangat all are numerical kan? All the input, so should be okay. Kita ada satu nominal, itu sensor itu tak apa sebab ini ID dia memang nominal, tak boleh tukar. Well, this is very unique label, okay? So cannot change to numerical, so leave it. So kita cuma interested in these two ni, temperature dengan pressure. Okay, tapi range dia berlainan. So you see the minimum for temperature is 200. For pressure is 1100. So the range is very huge, different. So it's not good for anomaly detection. Kita cuba normalize dulu. So now we proceed to the step normalization guna Z transform yang sama. So ini step 2 in design machine learning. So first you tarik itu retrieve. Okay, check. Sama ada okey tak? Alright, so nampak okey kan? Tak perlu tukar apa-apa. Tak ada missing value. Okay, integer cuma range dah perlu normalize. Okay. So, you pilih normalization. Okay, Z transform. Okay, check, tengok okay tak? Dia dah normalize. Okay. Tengok dia value dah normalize. So if you check the statistic, dia akan lebih closer lah. Okay. Dia takkan beza sangat. Okay. Alright, so now we go to the step 3. Identify machine learning algorithm. Right? Kita sekarang nak guna mana satu. Pergi operator, you select detect outlier distance. The first one tengok ni. Okay. Okay. Okay, cuba tengok what is under outliers. Okay, so dalam plot ini, dia ada dua parameter you kena set. Satu is number of neighbor. Okay. Number of neighbor means macam point yang close lah. Okay, macam you ada point sini. Right, so ini dipanggil neighbor lah. Ini bukan neighbor. Sini jauh. So dia cuma consider 10 yang close. Kalau you boleh letak 10, boleh letak 20 pun okay. Depend on how many data you have. Always they will take the average. You will take the average of the neighbor. Okay. So kita leave it dulu. Kita tak ubah. Number of outlier you nak detect, you can define. So sini kita biar 10 dulu Ini kena try and error sebab kita tak tahu berapa outlier yang kita nak. Kita try dulu tengok. Okay, tengok dia ada satu column outlier is false. So kalau you scroll down, okay, atau you click on outlier, you stop it, klik 2 kali dia akan nampak yang ada outlier akan sorted out. Ada nampak tak? Okay, so sekarang you kena counter check whether outlier itu betul tak. Ini where is the data sign lah. Kita kena guna experience kita untuk decide whether it is correct or not. Alright, so you check. Okay, out of 10 ini, berapa yang benar, yang outlier? You kena check itu range, you kena check itu range. Okay, so you see the normal range for pressure is between this and this. Ini ada outlier, ini include outlier, tapi average dia is 0. Average is 0. So outlier dia akan will be very far from the 0. Yeah. So kalau you check semula yang result tadi, okay. Ini outlier. Okay, ini sebab ini sangat jauh 11 Tapi ini okay kan? Dua ni. Sebab dia tak jauh sangat dari 0. So that means the number of outlier yang betul-betul outlier is less than 10. Ada 2 yang acceptable actually. So you kena adjust semula, pergi ke design. Okay, sekarang you kurangkan sikit. 8. Okay. So you run semula. Sekarang dah okay. So yang sekarang you betul-betul je lah outliers. Okay. Ini dikira juga sebab dia agak jauh. Tapi it's based on your own judgment. You're based on your experience. That's why you kena interact dengan machine learning. Guna human experience dengan machine learning. Identify the best solution. So, then you repeat until you get the outliers. So, from the outlier, now you can identify which sensor yang outlier. Which boiler. So, boiler itu yang kena maintain. Buat maintenance. Okay. So you apply the same concept, you can apply to our aircon, to our what else? Kita ada machine, server. Banyak server punya temperature. Kita punya server temperature. Dia boleh monitor temperature dia. Okay. Okay. So, tengok ada apa-apa lagi tak? Itu step. Then you present lah. So, this is your presentation. Okay. Okay, you boleh save ini, proses ini dalam proses lah. Save as a new file for anomaly detection. Okay, so now try the quiz anomaly. Okay. Kita ada sikit masa lagi, kita buat satu exercise lagi. Okay. Satu Okay, boleh sekarang you tukar tak? Tukar you punya answer. Nanti kita mark. Boleh tukar dengan Jilan your answer sheet. Ini bagi setiap orang satu answer dia. You mark sendiri ya. Mark untuk kawan. Alright. Nanti hantar. Ini sebagai rekod You tukar swap dengan your answer with your friend. Then you mark. Okay. So kita dah cover anomaly. Okay, we still have time. So can you open proses tadi ada save tak yang under classification ada? Saya nak you cuba dengan model yang lain. Yang ni. You for the yang ni. Okay, let's see. Okay, you pergi proses. Alamak, sini saya tak save. Ada. Okay. You proses, you pergi. You double click dia akan keluar semula macam ni. Okay. So your one will be look different lah. Sebab ini you guna logistic regression kan. So can you change the logistic regression to other machine learning model? You cuba type neural network sini. Okay, you boleh tampak sini. Okay. Actually you boleh pakai, you can try any machine learning yang advanced. Macam sini ada deep learning. Okay. Ada MLP, so on. Perceptron. Perceptron ni ini tak too simple lah. Ini sebab ini yang very early generation model. So normally we choose a neural network deep learning. So you cuba you ganti your logistic regression block itu dengan neural network. Okay, sebelum ini you run dulu dengan logistic regression. You take down the confusion matrix. You buat satu snapshot lah, confusion matrix macam ni. So saya nak you compare which one is more accurate. Okay, you buat satu snapshot untuk result ini, untuk logistic regression yang you dah buat. Okay, then you cuba tukar logistic regression to neural network and try semula. Ambil result yang baru. Okay, then you let me know which one is more accurate. Ah, tak apa. Okay, dah. Siapa yang dah? Nampak tak? So, dia punya ni. You boleh compare ni. Force yang ni percentage yang mana lebih tinggi? Precision atau recall? You check precision. Boleh? Boleh run tak? Ini boleh you boleh disable, you right click. You boleh disable dia. You click ni. Dia akan jadi disable.
So ini apa replace. Kita replace dengan neural net kan. Lepas tu never insufficient probability. Ini kita kena cover ke tak?
Dia ada error. Kalau ini dia okey tak?
Okey tadi.
You cuba bagi output dia. Masih ada error. Split does not have sufficient clarity to the given data set. Polynomial attribute. Kena tukar satu begitu. I check status. Tak, you pergi data dulu.
Sini ke?
Atau you ini you kasih disable semua dulu. You pilih semua. Tak gitu dia proses. You place ini semua. Okay, you disable. Right click.
Disable.
Alright. Dan ini tarik keluar dulu. Tengok. Okay, ini baru proses. Okay, tak apa, go back. Ini you activate semula. You right click ni. Right click, kasih enable. Ini you tarik keluar. Ini kena putus dulu. Check. Okay, keluar dulu proses. Sorry, tadi you pergi proses dulu. Ini tak sambung. You check statistik. Ada nominal lagi. Belum tukar. Ini kena tukar dulu. So you can make sure semua data ialah numerical. Okay. So kalau you try, you akan nampak result yang berlainan. Sama ada logistik lebih accurate atau neural network. So you boleh tukar model yang berlainan. So in machine learning, there are many methods. Maybe saya buat sikit additional knowledge lah. So machine learning, sama ada is a statistical method, or it can be used using neural networks. Like for example, support SVM. Ada satu method called SVM, right? Or you can use deep learning yang advanced, right? There are many methods you can choose. Okay. So this is how you select the model for different design. Let's select the best one. Okay, so as a homework, you can go back and try different model and compare the accuracy using the confusion matrix. You can do the same thing for, let's say, this one. Okay, regression model. Okay, for example, regression, let's say you try neural network. Cuba tengok boleh tak? Oh, ni belum keluar. Okay, so ini result untuk neural networks. So neural network dia akan look macam ni. So this structure of neural networks. Inilah hidden node, inilah output dia. So you boleh check dia punya output performance. Okay, example ini ialah 2963.76 2963.74 62. Ini yang neural network ya. Okay, kalau you tukar to linear just now, senang kan? You boleh compare. So ini berapa? 1968. So ini linear regression. 1968 point berapa? 84. So mana satu lebih baik? Which one? Error mana yang lebih kecil? So that means the model yang complex not necessarily the better choice. Kadang-kadang solution itu simple saja. Don't need to go for the very canggih or high end. Okay, best solution is a simple solution always. Okay. Ya, kalau ada dua solution, pilih yang simple. Sebab easy to maintain. Okay. Alright. Okay, so I think that's all for the exercise. Okay, let's recap. Kita ada 15 minit lagi, 20 minutes. Kita recap what I have learned. Let's go through. Okay, ada berapa jenis data? Tu. What? Okay, sudah. Berapa data? Ada mic?
Two, unstructured data and structured data.
Okay. So video is structured or unstructured? Unstructured. Okay. Wadi, bagi example yang unstructured lagi. Apa lagi?
Sound.
Sound. Okay. Document. Okay. Aziz, structured data selain spreadsheet apa lagi? Unstructured data, structured data.
Database.
Database, like SQL. SQL ialah structured data. Okay. Picture also unstructured, picture. Okay. Bagi satu additional knowledge. In machine learning, kalau unstructured data, selalu kita prefer lah transform to structure dulu. Sebab dalam structure you boleh guna banyak jenis statistical method boleh guna. So now actually a deep learning method is a very good method to convert unstructured become structured. So macam you process image processing itu semua very unstructured kan. So that's why kita guna deep learning untuk convert jadi structure dan boleh extract feature dia. Okay. So what is machine learning? Fahan?
What is machine learning?
What is machine learning?
Machine learning algorithm is a computation model that's learn information from
Okay.
data.
So human learn from what? Human learn from
Human
experience.
experience
Machine learn from what? Data.
from data.
So data is an experience to machine, right? Machine learning. Okay. Ada berapa proses dalam machine learning? Berapa? 5.
5, Prof.
Apa tu? 5.
Apa tu?
Step 1.
Asking the right questions,
Step 2.
understanding, obtaining and preparing the right data,
Okay.
identify, apply machine learning algorithm,
Okay.
evaluating performance, and
Okay.
using and presenting the model.
Okay. These are the 5 steps. So apa beza data science dengan machine learning? What is data science? Asano?
Data science is science of knowledge.
Ah.
From information learned from ML, machine
Ah.
learning.
Ah.
That's all.
So apa beza dia? What is the additional thing dalam data science?
Data science. Insight. Knowledge and insight.
Insight dari mana? Dari machine ke dari human?
Daripada human.
Human. Because human experience kan. So kita combine information for machine dengan insight for human, kita jadi knowledge. So this data science. Science of extracting knowledge. So apa itu rapid miner? Senang tak rapid miner?
Tools.
Perlu coding tak? Perlu programming tak? Tak perlu kan? Very user friendly. Tarik saja.
Kena tahu operators dia tu.
Okay, so rapid miner is a tool that can implement machine learning without coding. So in future, kalau you nak implement, you boleh start lah dengan rapid miner. Even though you tak ada programming background pun tak apa. More important, understand the 5 steps of machine learning. Then you just choose an operator, connect them, test. Of course, you need to clean your data lah. So bila you prepare data, what are the steps that you need to clean? Kena identify what untuk cleaning data. First, check ada apa? Missing. Then data type. Macam clustering tak boleh guna nominal. So kena convert dulu. Satu lagi? Siapa boleh? Ada hadiah? Masih ingat tak apa transform? Kalau range tak sama macam mana? Data range tak sama. Apa tu? Normalization. So kena change to range dulu. Kalau range memang beza, so buat normalization dulu. So ada banyak normalization technique lah. Z transform is what you study in this lecture. So you have learned, right? So congratulations, kan? You have complete the module. So what you have learned? Berapa case study you belajar hari ini?
House prediction.
House prediction itu apa? Regression or classification?
Regression.
Regression. So regression is label is what? Value ke atau label atau name? Value. Value. You predict value or number.
Yes.
Yang second case study?
Patient data. Patient.
Okay. Patient data itu supervised, unsupervised?
Unsupervised.
Yes, unsupervised. Okay, kita group patient sebab kalau tak ada label kan. So kita group itu patient into high risk and low risk. Okay, apa lagi yang you belajar use case? Boiler. Itu apa? Untuk detect what? Anomaly. Ini penting untuk maintenance prediction lah. Okay. Okay, last kali. Classification tu. Apa tu? Kita classify siapa potential customer. Kan? Online business. E-learning, e-business. Okay. So you had learned prediction, house price with regression algorithm, identify prospective customer using classification, segmenting patient data using clustering algorithm, and distance-based anomaly detection for a boiler. So you almost learn everything, different way of machine learning used without coding. So in future, you can actually refer to this model for your own application. So what is the learning point? Okay, you have learned how to implement machine learning model for data science using RapidMiner. Okay, so there are 3 points you are learning. First, you have learned the core concept of data, machine learning, and data science. Second is, you have learned the basic of RapidMiner. Agree or not? Betul Yes. And the third is, you have learned how to build machine learning model using RapidMiner. Do you agree? Yes. Okay, semua, do you agree you have learned these 3 things? Yes. Okay. So thank you very much for attending this workshop. You have any questions? Okay, by the way, boleh you go to the feedback form. Online tu, ya, yang itu Google feedback form untuk apa? Ada satu form workshop feedback. Boleh you tolong isikan Kak? Okey, yang apa tu? Answer untuk boleh collect answer. Okay. Okay, very good. Semua betul. Alright. Okay, so I think that's all for today's workshop. All right, thank you for your presence. Okay, thank you very much. So see you in the future. Hopefully we will have another advanced module. Okay, all right, thank you.